Hello, I'm Mr. Steinauer, and this is 3rd and 4th grade science. Today, we'll be talking about motion and acceleration. All you'll need for this lesson is a notebook and something to write with. That's going to help you keep track of any vocabulary that we use for this lesson, and it's also going to help you write down what you're going to do when the lesson is over. Before we get started, let's review some vocabulary from our previous lesson last week. Last week, we talked about forces. A force is a push or a pull in any direction. Forces can push away or they can pull toward. Before we explore motion and acceleration, let's first understand the definitions of both of those concepts. Now, motion and acceleration are each a process. A process is just something that takes time. And motion is the process of changing position. Position is just where something is at that moment. There's a book behind me and a book right beside it. They're in their current position. If I switched their position, then they will have both been in motion. Things are in motion all the time. Even though it seems like the Earth isn't moving, it's spinning at over 1,000 miles per hour. Everything on Earth, everything in the universe is in motion. Our bodies are constantly in motion. We drink water, and that water is in motion throughout our entire body, hydrating us. We are also in motion in our day-to-day lives. Now, this is a good time to define acceleration. Say that after me. Acceleration. Acceleration is the process of speeding up an object in motion. So if I were to switch these two books, if I were to put them in motion, if I did it really quickly, they would both have a greater acceleration than if I took my time to change their position, to put them in motion. Acceleration can only happen while objects are in motion. For today's lesson, and for the next couple of lessons coming up, we're going to learn a little bit about Sir Isaac Newton. Isaac Newton lived over 300 years ago, and he did a lot for our current understanding of science and mathematics. From a scientific perspective, he was the first to describe gravity. He was the first to theorize that sound travels at a certain speed. And, as is pertinent to our lesson, he was the first to observe and explain what he called the 3 laws of motion. Acceleration has to do with Newton's 2nd law of motion. In future lessons, we'll talk about Newton's 1st law and his 3rd law of motion. But today, as we're learning about motion and acceleration, let's talk about his 2nd law of motion. Newton's 2nd law of motion says that the acceleration, the speeding up, of an object depends on 2 things. It depends on its mass, how much stuff is inside of it, how much matter an object is made of, and on the force that's used on it. And now, let's bring it home, back to our homes, where we're going to find evidence of Newton's 2nd law of motion. You might be wondering why I have a mandarin orange and a wad of paper right next to each other. That's because I'm going to use these 2 objects to prove Newton's 2nd law of motion. Now, while they're about the same size, one of them has a lot more stuff in it. The mandarin orange is full of fruit and juice and is surrounded by a waxy skin. This wad of paper is just that. It's a wad of paper. One of these has more mass or matter inside of it than the other one? Which one has more mass? That's right. The orange has more matter inside of it. It's much thicker and much more dense than the wad of paper. So now I'm going to move this black platform. I'm going to angle it up so that I use the same amount of force on each object. So the mass of each object is different, but the force will stay the same. Which object will speed up the most? Which one will have the greatest acceleration? Let's find out. So which one of these had greater acceleration? That's right, the orange. If we watch again, we'll see that the orange rolled faster than the wad of paper. Now there were other things happening too, right? There was the force of friction that pushed back against these as they rolled down. But overall, we could see that the second law of motion is true. The orange, which had much more mass and the same amount of force as the paper wad, rolled much quicker. It had greater acceleration. Now let's say we want the paper wad to have more acceleration than the orange. What could we do to give the paper wad more acceleration? Yes, we could change the force that we use on each object. Now, it's not going to make for a fair race, but this is simply a demonstration of Newton's second law of motion. So if I were to take each of these objects, and let's say I lightly tap on the orange, but then I flick the paper wad, which one had greater acceleration that time? And why is that? That's right. The paper wad had greater acceleration because greater force was used on it. Even though the orange has greater mass, there was way less force that I used on the orange. So its acceleration was a lot lower than the paper wad. Now it's your turn. Find evidence of Newton's second law of motion by comparing the acceleration of two different objects. Now we compared the force and the mass of two objects in motion. One way you might test Newton's second law of motion by changing forces at home would be taking two basketballs or soccer balls and using a different amount of force on them and compare how much they accelerate. So with a basketball, you might dribble one really hard and the other you might dribble lightly. With a soccer ball, it's just a matter of kicking them. Another way you could find evidence of Newton's second law of motion when comparing mass would be to find two relatives or two friends who are different sizes. Have them get on their bicycles and try to use about this same amount of force and see which one accelerates quicker. When you've found evidence of Newton's second law of motion, either write about it and share that with a loved one, repeat your experiment and share that evidence with a loved one, or take a video or photos of your experiment and the evidence for Newton's second law of motion that you found, and with a loved one's permission, share it on social media and tag KCPS Homeroom in it so that we can take a look at what you've done to prove Newton's second law of motion. This concludes our lesson together. It's been my pleasure having you in class today. I'm Mr. Steinauer, and I'll see you next week.